Work it, make it, do it, make sense.
We're at Devoxx UK and I'm here with Steve from IBM, and you gave a talk about the anatomy of Java vulnerabilities.
I did, which I've just literally an hour ago.
I just felt like reminding you.
Yes, thank you.
You're welcome. And so that's a very interesting topic at the moment, well, always, especially in developer community that has a strong focus on Java. I'm not too au fait with the history of Java vulnerabilities, but in your opinion, what's the biggest historical one that is now resolved?
Well, it's
or maybe
so Java for a long time had a really bad rap for security, and in the external world, people would say, "Don't you uninstall Java because it's full of vulnerabilities." What they really meant was, "Don't use the Java plugin because it had a lot of vulnerabilities," and a lot of that was design issues, and so. There's no particular. I mean, there's always vulnerabilities, and in popular software, there's always lots because people are actively trying to find them.
Yeah.
So it's hard to say that's a killer. What we suffered from for a long time was this bad perception, and we've fixed that because the Java plugin, it is the main vehicle for letting people get at vulnerabilities has gone away. The browsers have stopped doing it. Oracle are redoing their support and that sort of stuff. So that's cool. So now we're back to having a runtime that you could look at more objectively. And again, if you look at there's a few vulnerabilities. There's never a large number. We have, I think it's like they fix like 10 every time they do a release. It's not massive. Occasionally you get one or two that's a bit painful and you should fix it, but there's no big smoking guns. Okay?
So it's more of a gentle undercurrent.
It's no worse than a lot of other products, which is the best way to put it. So my talk was about level setting people's understanding of it, but also trying to make people aware of the other side of the coin, which is what's happening in the cybercrime space.
Okay.
Right. So what I want to do is make sure people understand the scale of the problem. So you can talk about Java vulnerabilities. You can ask people to update, and they see that as a chore because every time you update to a new version, you run the risk of breaking something. But if you don't update, and the thing that you're running on gets old, or maybe not even very old, it's got vulnerabilities in it which become known. So once they become known, they can be exploited. And there are people out there who are making serious money in hacking your systems. So according to some of the stats that we've got, the cybercrime, which is so we could talk about espionage and stuff like that. We talk about cybercrime as being the most obvious one from a real day-to-day point of view. Cybercrime 2016 was from a criminal profitability point of view equal with the whole of the drugs trade, and it's projected to get to something like $2,100 billion.
Wow.
So it's going from about 450 now to about $2,100 billion.
Is that American billion or?
American billion, yeah. But it's just, there's no end of it in sight because we've not really taken security that seriously. You see it all the time in the press. So my talk was wake up and see this side of the problem. And then we were talking then through what a vulnerability is and how the processes are managing it. And then talking through a few examples of what are vulnerabilities, but without talking about the code, because if I share with you the code of a vulnerability, if I show you the fix, or I point out how the code that you've written is going to get hacked, if I publicize that, then I've given away those secrets to the bad guys.
Yeah.
So I always say it's the same as if I was tweeting my credit card and PIN number.
Yeah.
I'm not going to do that, so we're not going to share the details of the fixes. Yeah.
So when you're looking at so we're not going to talk about specific problems and fixes.
I could talk about some examples. There's some classics. So people always point at things like Java serialization as being a really classic way for vulnerabilities to be built around. So exploits. So vulnerability is the weakness, and the exploit is the thing that somebody's created to make use of that vulnerability.
Can you intercept a database connection?
Yeah, in theory. So
is that when a serialization would be?
So the simple answer is yes, you could, but it depends on the circumstances. So serialization, the reason that serialization gets targeted is because of the design of the serialization. It means it's very easy to instantiate arbitrary code. So you can't inject code, but you can find code that people have already got on their system and subvert it. So if you've got data-driven code, which actually a lot of code is, it's very easy to subvert that and end up it doing what you weren't expecting. But the things like you've heard about SQL injection.
Yeah.
So there are moral equivalents in Java where you can see people where the designer of the application has not checked the data, so he's not validating it. Somebody discovers that out. Somebody connects his application or his code with another piece of code and another piece of code, and then you've got this exploit. So it's not always a one-for-one, this vulnerability, this exploit. It will be a series of weaknesses in your code combined together.
Presumably, if you design your APIs in a certain way, then to a certain degree, type safety saves you.
So that will definitely help. Right now, I'd say most of the vulnerabilities that turn up are not obvious. So they're not, so they're not smoking guns. So if you could look at, so an example that I used today was a bug vulnerability has been fixed for a long time, but effectively because somebody was being helpful, they were giving away information. So this was an instance where you used some data to instantiate a class. And if the class couldn't be instantiated, you got a message back that said can't instantiate the class, and you gave the class name. And this all revolves around the Java properties object, which was backed by the system properties object. And the vulnerability was that if what you were asked for wasn't in that properties object, it would go to the system one.
Okay.
And the net was that if you were to ask for some random property, it would come back and say, if you said, instantiate the class that's called java.home, the property construction would go, java.home, haven't got it, it's in the system class loader, in the system properties, java.home, try and create a class for it, that fails, and you get back a message that says java.home can't be turned into a class because its value is this. Right?
Okay.
And it's those sorts, that's what vulnerabilities are, those really subtle things where either you didn't realize how your code was going to be used and you didn't think about it, or in lots of cases you did think about it, but somebody who was very intent in trying to break your system is connecting your code with somebody else's code, stuff like that. Yeah. So what we're saying really is right now is it's a big problem. There's a lot of focus, a lot of money being made by people who are exploiting you. So you have to remain current. And the more that you can do to keep your systems current, the more safe you're going to be. And we appreciate that that means you may end up having to, your applications may break because you put the latest version of something on it. But the downside of not fixing it is that the older your software is, the more vulnerabilities will be discovered in it, and the more likely is you'll get hacked.
Work it, make it, do it, makes us